Welcome to the Ship Corrosion channel. My name is احتشام زاده. An introduction to this channel is available on video number E28. Chapter 2, Section 11, Thermodynamics of Electrochemical Reactions. Pourbaix diagrams of some industrial significant elements. The reference is Fundamentals of Electrochemical Corrosion, ASM International. Pourbaix diagram for the gold wire system. The hachures are introduced here: corrosion by dissolution, corrosion by gasification, passivation by oxide or hydroxide layer, passivation by hydroxide layer, and immunity. The distinguishing features of this diagram are the wide immunity zone and the absence of a passive zone. Pourbaix diagram for the silver wire system. Immunity, corrosion by dissolution, passivation by oxide or hydroxide layer. Pourbaix diagram for the platinum wire system. The distinguishing features of this diagram are the wide immunity zone and the negligible corrosion zone. Pourbaix diagram for the mercury wire system. The distinguishing features of this diagram are the wide immunity zone and the absence of a passive zone. Pourbaix diagram for the copper wire system. More detailed diagram is also shown in this figure. Immunity zone, corrosion by dissolution, passivation by oxide or hydroxide layer. Pourbaix diagram for the iron wire system. Immunity region, corrosion by dissolution, passivation by oxide or hydroxide layer. Also, more detailed diagram for the iron wire system can be seen in this slide. Pourbaix diagram for the nickel wire system. Immunity region, corrosion by dissolution, passivation by oxide or hydroxide layer region. Pourbaix diagram for the chromium wire system. Immunity region, corrosion by dissolution, passivation by oxide or hydroxide layer. Please do not hesitate to put your suggestions in the comments section. Pourbaix diagram for the aluminum wire system. Small immunity zone, corrosion by dissolution, passivation by oxide or hydroxide layer. Pourbaix diagram for the magnesium wire system. The distinguishing features of this diagram are the wide corrosion zone and the absence of an immunity zone. Corrosion by dissolution, passivation by oxide or hydroxide layer. Pourbaix diagram for the zinc wire system. Immunity zone, corrosion by dissolution, passivation by oxide or hydroxide layer. Pourbaix diagram for the lead wire system. Immunity region, corrosion by dissolution, corrosion by gasification, passivation by oxide or hydroxide layer. More detailed Pourbaix diagram for the lead wire system can be seen here too. This region is corrosion by gasification and this region is corrosion by dissolution. Also, there are a passivation region by oxide or hydroxide layer due to PbO, and Pb2O4 and PbO2. Pourbaix diagram for the term water system. Immunity region, corrosion by dissolution, corrosion by gasification similar to lead, passivation by oxide or hydroxide layer. Pourbaix diagram for the titanium water system. A very small immunity region, corrosion by dissolution, and a wide region of passivation by oxide or hydroxide layer. In this diagram, the passivation region is very wide. Pourbaix diagram for the tantalum water and niobium water systems. The significant features of this diagram are the absence of corrosion zone and a very extensive region of passivation. Pourbaix diagrams for the antimony water and arsenic water systems. Antimony, arsenic water system. There are no passivation regions in these diagrams. Corrosion by dissolution, immunity region, and corrosion by gasification. Pourbaix diagram for the carbon water system. Corrosion by dissolution, corrosion by gasification, and a very small immunity region. The significant features of this diagram are the wide regions of corrosion by dissolution and corrosion by gasification. Thank you for your time and attention. Challenge number 38. If you'd like to challenge yourself, please answer these questions in the comments below. 1. Compare Pourbaix diagrams for lead and tin with iron. 2. Interpret the Pourbaix diagram for magnesium considering the standard redox potential of magnesium, which is Mg2 plus 2 electrons yields Mg. E0 equals negative 2.356 volts versus standard hydrogen electrode.